So next we're going to take a look at the positive and negative intervals of a graph. So if we take a look at this graph here, so positive means that the function is going to be above the x-axis. So when we're looking at this graph, we got to pay attention to this x-axis here. So positive means above the x-axis because that's where the positive y values are. And then negative means when it's below the x-axis because that's where the negative y values are, okay? When you are going to write your intervals, you are going to do just like you did with increasing and decreasing, and you're going to make sure and you're going to use your x values when writing your intervals. And because where it changes directions, it'll actually be changing directions on the x-axis, so it'll be neither positive nor negative. So you're also going to be using parentheses instead of brackets here. All right, so positive above the x-axis, negative is below the x-axis. We're going to be using the x values, and we're going to make sure that we use parentheses. So looking at this graph down here, I'm going to go ahead and do the negative parts first. So negative is going to be when it's below the x-axis. So I'm just going to draw these lines on here just to show us. These are the two places where it's below the x-axis, okay? We're using x value, so we want to make sure we put our negative infinity and positive infinity here. Just so we remember, this is the left side where the x's are really small, right side where the x's are really big. So if we go ahead and do our negative interval, so we said that's here where we have these pink lines. So if you look, this is a 1 here, okay? And then it's going to be negative this entire graph over here. So for any x value smaller than 1, it's going to be negative. So we're going to use our interval from negative infinity to 1. Because we have more than one interval, you're going to make sure you put a U, which stands for union, means you have more than one. And if you look down here, this is at 3, and then this is at 5. So from 3 to 5, it's also going to be below the x-axis, so it's going to be considered negative. So then our positive, we have two sections that are positive, so those in orange. So these are my two sections. And remember, this does keep going on forever if it's not indicated by a tag. So for my positive interval, the first one here, it goes from the 1 to the 3 is going to be positive. We're going to make sure we use parentheses. Then I have another one, so we have to make sure we use U for union. And then it goes from 5, and everything else for the graph is going to be positive. So 5, and then we're going to do to infinity. All right, so positive intervals above the x-axis, negative intervals below the x-axis. We're making sure we use parentheses because where these actual numbers are, it's actually 0 because it's on the x-axis, so those are not included. Okay, so that's positive and negative intervals. So next, we're going to take a look at boundedness. Okay, so boundedness just means, is the graph bounded? So the easiest way to do this is to draw a line above the graph and below the graph. And if it does not cross the line, that means it's bounded there. If it does cross, then it's not bounded there. So in our first graph here, if I draw a line here, will this graph ever cross that line? No. And the reason is because it ends here, so the graph doesn't keep going on forever. So it's not going to cross on the top. And if I draw a line on the bottom, is it ever going to cross on that line? No. So this is considered bounded above and below, and so we just call that bounded. So if it's bounded above and below, then that's just considered bounded, okay? So that graph is bounded by those two lines. All right, so next one to the right of that, if I draw a line on top, that is never going to cross. But if I draw a line on the bottom here, these have arrows, which means if we keep going, so it will cross. So only the top works. So we would just say this is bounded above. Okay, you don't even have to write the not bounded below. If I asked you about it, you would just tell me that it is bounded above. So then our next graph down here, if I draw a line on top, well, because these have arrows, this means that it would cross, so it's not going to be bounded above. If I draw a line below, it will be bounded there. So we would consider this to be bounded only below. And then my last example, if I draw a line on top, it will cross, so it's not going to be bounded there. And if I draw a line on the bottom, it's going to cross, so it's not bounded there. So we would just say this whole graph is not bounded. Okay, so there's just 4 different options here. It can be bounded, which means top and bottom is not going to cross. It can be either just bounded above or just bounded below, or it could be not bounded if it's going to cross at the top and at the bottom. So bounded is just means, and if you look back at the question, it asks, are there upper or lower limits on the y values? So in other words, the highest that the y value can go or the lowest that the y value can go. So that's what boundedness is. All right, next thing we're going to look at is extrema. Okay, so extrema is another way of saying max and mins. But the difference between local and absolute extrema can get people confused sometimes. So guys, any max or min is local if it changes directions. So what does that mean? If you have a maximum, so if this is a maximum right here, this goes from increasing to decreasing, so it changes directions. Whereas if it was a minimum, it changes from decreasing to increasing, so that's a minimum. So it doesn't matter where it is, as long as it changes directions, that's going to be called a local extrema. In order to be considered an absolute extrema, this has to be the highest for it to be the max, or the lowest for it to be the min point on the graph, and the entire graph that's given. Okay, so for it to be absolute, it has to be the absolute highest or lowest point. So there's a difference there. And then just remember, when we refer to extrema, that means we're referring to max and mins. Okay, so we have this graph here. It's like graphs on your calculator. They are telling you that we have a minimum at this point right here, but other than that, that's all we know. So the first question says, how many local maximums does the graph have? So for something to be considered a local maximum, so I'm just going to draw a picture of the max, that just means it has to change from increasing to decreasing. So we're just looking for anywhere on the graph that changes from increasing to decreasing. So if you look right here, see how the graph is increasing, then it decreases? So this would be considered a local maximum. So we have one local maximum, and we'll just draw an arrow there. All right, then it says how many local minimums. So for it to be a local minimum, think about a minimum, that just means it has to change from decreasing to increasing. Okay, so if you look here, we have decreasing, then increasing. So we have one here. And then if you look again, we have decreasing, then increasing. So we have one here. So we actually have 2 local minimums here and here. Okay, doesn't matter if one is lower than the other for local. Local just means it changes directions. Okay, but then it asks, is there an absolute max or min? Now, absolute max or min means it has to be the absolute highest or lowest point. So if you look at this graph, because this keeps going forever, there is never going to be a highest point. It just keeps going up forever and ever and ever. So there's not going to be an absolute max. Okay, and once again, it's because there's no highest point. It just keeps going on forever. For the absolute min, though, the graph keeps going up, but it doesn't keep going down. So this right here is our lowest point, okay? So we have one absolute min, and the reason we have that is because it's the lowest point. That's the lowest point on the graph. Okay, so that absolute min is actually a local min as well because it changes directions, but it is an absolute min because it is the lowest point. Okay. And then at the bottom it just says, remember, extrema refers to y values. So if I ask you to write about the extrema, you would use the y values here. So what does that mean? So if we were going to write a statement about this graph, we could say there is an absolute minimum at, and if you were going to tell me where it is, you would use the y value. Well, remember they told us this point, so we would use this y value here is negative 24.05728. So whenever you're referring to absolute max or min or local max or min, make sure you're using the y values. That's different than the intervals that we looked at earlier. Okay, so local max and local min. And then we have absolute max and absolute min. Just remember there is a difference. Absolute has to be the highest or lowest. Local is just changing directions.